Hello and welcome. So we have a couple of different exponent properties here. Now all of these, we'll notice, are a little bit special because they're all fractions. Now that doesn't make them any different from your regular exponent properties of whole numbers. They work the same way. The only difference is that you just have arithmetic with fractions. All right, so let me remind you of some of the basic properties and we'll go from there. So for example, this first one, if I have something like x squared times x to the third, well, if I'm multiplying two bases together that are the same, their exponents can add. So in other words, we get x to the fifth. Now here we have the same base with multiplication between them, which means I am adding my exponent. So g to the 5/7 plus 3/10. Now keep in mind, in order to add two fractions together, they need to have a common denominator. The least or smallest common denominator between these two numbers, 7 and 10, is going to be 70. So then what do I need to multiply 7 to get to 70? That would be 10. So multiply top and bottom by 10. Other side, 7 needs to be multiplied to get to 70. So then we have g to the 10 times 5 would be 50 70ths plus 21 70ths. And that would give me g to the 71 70ths. Because 50 plus 21 is 71, and then when you add fractions, the denominators do not change. So there is my first exponent property. So that would be g to the 71 over 70. Okay, and I'm going to stress that's not 7170 written largely. It's still an exponent. It's x to the fifth, meaning it's kind of levitating above the x. That fraction should not be off to the side. It should also be small and levitating above your g. All right, so do keep that in mind when you're entering these in. You're like, why isn't it working when it looks like you have a fraction multiplying? It's a power, not multiplication. All right, let's keep it running. Now this next one, just a reminder on the property with whole numbers. Right, the property of whole numbers says if I have a same base with division, then I subtract my exponents. So in our case here, we have a b to the 5/13 minus 1/6. Because I have, it's always going to be in this property, numerator minus denominator. It's a little harder to tell. Typically, when on this one, I like to say that whatever has the largest amount, when we do that subtraction, wherever the largest amount is, either numerator or denominator, that's where it ends up. So for example, we had more x's in the numerator, which is why it's technically in the numerator after that subtraction. But the property itself is directly numerator minus denominator, so that way with fractions it makes it a little easier. So let's actually do this. So least common denominator between 13 and 6 is actually just going to be whatever 13 times 6 is, which I believe is 78. All right, so we're going to multiply 6, top and bottom, get those common denominators. And this will give me b raised to the 30 78ths minus 13 78ths. And then 30 minus our 13 here, and we're going to get 17. So b to the 17 over 78 in the exponent position. So b 17 over 78. Now this next one is power to a power with whole numbers. What that looks like is if I have something like x squared to the third, that's x to the 2 times 3. In other words, x to the 6th. All right, so when I'm multiplying something with a fraction, reminder, even with whole numbers especially, right, write them as a fraction, and then fractions multiply straight across. So 2 times 3 is 6. 5 times 1 is 5. So c to the 6/5 is your answer. Done. All right, now negative exponents work the same way as well, where if I have something like x to the negative first, Reminder that moves it from numerator to denominator, and after it moves, it turns positive. So what's left in my numerator is technically x's coefficient, right? It had a times 1 in front, which is why it'll leave it as x to the positive 1 before. So same thing here. This y isn't a fraction currently, which means it's over 1. So then I will get 1 over y equals positive, because it moved to the denominator, 8 over 19. Okay, that looks a little too big. I'm going to shrink it down a bit. There we go. And there you have it. That's the negative exponent. And then it can go the other direction as well, right? If I start with a negative exponent, it can move back into my numerator. And then when it does, it just multiplies to what's there and turns positive after that move. So here we see a b to the negative 1/12, which means it moves into the numerator and turns into a positive 1/12. Now technically that leaves an over 1, but the division by 1 isn't going to change anything, so it's okay to drop that. In fact, it's more simplified to keep it. To drop it. So keep it the way it's currently written, but to drop that negative. Drop the positive 1 in the denominator. My goodness. All right. Well, that is your basic properties with rationals as the exponents, as fractions. Thanks for watching.